This is Climate Watch. I'm Zhao Ying. Welcome to the show. A deadly hantavirus outbreak aboard the MV Hondius cruise ship has captured headlines over the past few weeks. The World Health Organization has so far recorded 13 confirmed cases linked to the outbreak, including 3 deaths. But beyond the immediate public health crisis, scientists suggest this could also be a warning sign of climate change. Hantavirus has circulated in rodent populations for thousands of years. Yet changing weather patterns, habitat disruption, biodiversity loss, and rapid urban expansion are allowing these rodent hosts to thrive in new areas and heightening the risk of zoonotic spillover. In Argentina, where this cruise ship outbreak is believed to have originated, hantavirus cases have almost doubled in the past year. The country's health ministry says climate change is driving the appearance of cases outside historically endemic areas. So is the hantavirus outbreak also a climate story? Is it part of a broader shift in how infectious diseases emerge in a warming world? And could this be the wake-up call that we need to rethink our relationship with the natural world? To answer these questions and more, we are joined by Dr. Kirk Douglas, Director of the Center for Biosecurity Studies at the University of the West Indies in Barbados. He's been studying the connection between hantaviruses and climate change. Dr. Douglas, it's great to have you with us.
Thank you for having me. It's a pleasure to be here.
Hantavirus is an ancient family of viruses that has existed long before industrial warming. So when scientists talk about a possible climate factor today, what exactly do they mean?
Well, I believe some people have heard of hantavirus before. People who live in North America, for instance, the first incident was in 1993, before Corner's outbreak, where a number of persons contracted the hantavirus pulmonary syndrome, as it was called after that incident. But these are ancient viruses that are maintained in rodent reservoirs over a long evolutionary time. What climate scientists and disease ecologists mean today is not that climate change created hantavirus, but that climate variability and that climate change can alter the conditions that govern the spillover. Because climate affects rainfall, drought, vegetation, food that might be available for rodents, breeding success of the rodents, survival, movement, and also, most importantly, the likelihood that these rodents will enter spaces where humans will frequent and therefore increase the risk of human-rodent contact. And this is where the problem lies.
When we look at South America's climate data, we see a historic drought from 2021 to 2024, and that was followed by heavy rainfall last year. So in climate epidemiology, how can that kind of rapid shift trigger rodent population booms and increase the risk of spillover into humans?
Well, oftentimes when you have a prolonged drought, that suppresses vegetation. So not a lot of growth for plants and trees that can provide food. So that means that rodents have to be very resourceful. And if they're not resourceful, then they die. However, when you have heavy rainfall after a long drought, vegetation and seed production can rebound quite rapidly. And this creates an abundance of food for rodents. And if conditions are favorable, then rodents will also reproduce just as quickly. And the juveniles of the rodents will survive, and populations can then sharply expand. And this population boom increases 3 risks. The first, more rodents mean more opportunities for virus transmission amongst rodents. Second, competition for food, space, and breeding mates can also increase aggressive encounters. And this is one of the primary routes through which hantavirus spreads from rodent to rodent. Oftentimes, you'll find males are often more infected than females because of the aggressive behavior that rodents are known to have. And third, when rodent numbers rise, they are more likely to move into human environments. like houses, sheds, farms, campsites, even like we saw landfill sites as well. So the recent reporting on Argentina describes a type of wet period rodent boom, which is locally called a rotada in South America. After years of drought and then a wetter 2025 cycle, then you could find the linkage between increased rainfall, increased vegetation growth, and then rodent population, something we call the trophic cascade. So droughts can compress the system, rainfall can reload it, and then human exposure can then reignite or ignite an outbreak.
Okay, and your study suggests that unlike rainfall, temperature doesn't have a consistent effect on hantavirus risk. Like it can increase the risk in some ecosystems and reduce it in others. Can you explain more on that?
Sure, no problem. Temperature is more complex than rainfall because it operates differently across ecosystems. In a cold environment, warmer temperatures may improve rodent survival, also extend breeding seasons, reduce winter mortality, or allow the rodent reservoirs to expand into areas that they were previously marginal or even non-existent or absent. But in a hot, dry ecosystem, additional heat may actually do the opposite. It would reduce survival, dry out vegetation, reduce food availability, and push rodents into different habitats. So temperatures do not act like a universal switch. It acts or interacts with rainfall, humidity, vegetation, the altitude, if you're, at sea level or you're at a higher altitude, seasonality, obviously land use management, housing conditions, and the biology of the local rodent hosts. That is why our study found that rainfall often gives a clear ecological signal, while temperature is more context dependent. It depends on where the ecosystem is located. So the key message would be that temperature matters, but if its effect depends on the ecosystem. Rainfall often acts more directly through the trophic cascade, as I mentioned, with the increases of food availability linked to rodent reproduction.
Yes. So actually, when people think about climate change and disease, they often picture tropical diseases like malaria or dengue fever marching into cooler parts of the world. But in the case of hantavirus, the impact is nonlinear. So does that also make the climate signal less obvious and perhaps harder for the public to perceive?
Yes, because as I mentioned, hantavirus is a climate sensitive disease. There's no direct when the temperature increases, the next day you will have hantavirus. There's always a lag period because there are other things that have to go on first. If you can envision the domino effect, where you have a line of dominoes standing on end and you push the first domino, there are a series of dominoes that will fall, but that last domino that falls is what we would consider being that terminal effect that people usually notice, that symptom. But there's several stages before then. And that is what oftentimes may cause the complexity around the linkage with climate and, in this case, hantavirus disease.
Okay, and we know that scientists are watching for a strong El Nino event this year. How could El Nino affect the spread of rodent-borne diseases like hantavirus?
Very good question. So El Nino is important because it reorganizes rainfall and temperature patterns across large regions in the world. In some parts of South America, El Nino can bring heavier rainfall and vegetative growth. In other areas, however, it can contribute to drought or heat stress. And for hantavirus, the effect depends on which ecological pathway is the most dominant within that local area. So where an El Nino brings rainfall after dry periods, it may increase vegetation and food resources, supporting rodent population growth. Where it brings drought, it may push rodents towards human settlements in search of food and water. In both scenarios, the public health concern is not El Nino alone, but El Nino interacting with land use management, agriculture, housing, tourism, waste management, and obviously surveillance capacity as well. So the NOAA Climate Prediction Center has issued an El Nino watch, and that was on the 14th of May, stating that El Nino is likely to emerge during May to July of 2026 and may continue through the Northern Hemisphere winter, while also noting there is some uncertainty about peak strength. So El Nino is not a guarantee of outbreaks, but it is a climate signal that should trigger preparedness, coupled with rodent surveillance and, if possible, early warning systems.
Yeah, and just now you mentioned some human factors like urban management, agriculture, and we know that one striking feature of this recent outbreak in Argentina is that the cases are appearing in areas not traditionally considered high risk. So, to what extent is this driven by animals responding to natural environmental changes versus these human driven factors like urban expansion and land use change?
I would say that both are important. But for me personally, I think human behavior by far is the single most critical factor when it comes to disease outbreaks. Because going back to your first question, when you mentioned that hantavirus is an ancient virus, and it is an ancient virus. So this virus was around for quite some time. So what has changed? Maybe yes, the topography, maybe a bit of the geography has changed somewhat, but primarily what we often find that is at the root of several outbreaks is oftentimes human behavior. Humans often go places that they aren't usually supposed to be, and they then do things that they ought not to do or they wouldn't normally do. And this brings them into closer contact with the reservoir, in this case, the rodent, and then exposes them to infection by the pathogens that live and circulate within these reservoir hosts.
Yeah, and actually, this outbreak on the cruise ship, the MV Hondius, may have originated during a bird watching near a landfill in Ushuaia. How do climate change and human waste management practices kind of interact to create hotspots for zoonotic spillover?
Well, the importance here is that first we have to be cautious that the exact source of exposure is still under investigation.
Yes.
The landfill link burden expedition is one possible hypothesis, but it has been disputed as well. And uh, I wouldn't necessarily call it an established fact at this point in time. However, when you do have waste in the environment, this will attract rats and rodent mice as well, because they see it as an opportunity to have food and to support the rapid reproduction that they would seek to do. So if you have poor waste management, this provides food and also shelter for rodents. And so this is important that you ensure that your waste management systems are functioning at the highest level and that you reduce the availability of food in the form of waste to these rodents in an effort to control the rodent population.
Your research also pointed to agricultural systems like sugarcane and maize as creating favorable conditions for rodent hosts. So, are large scale industrial farming practices kind of unintentionally increase the zoonotic risk?
It's an interesting question. Agriculture can unintentionally increase rodent-borne disease risk when it creates abundant food. It also creates cover and shelter, nesting sites, provides irrigation water because these agricultural sites need to be irrigated, and then the post-harvest residue. If you're thinking of a grain crop, for instance, if the large harvesters go through, they will harvest primarily a good proportion of the crop. but there will still be residual um, parts of the crop in the field, and this will attract rodents. Crops like maize, sugarcane, rice, and other grain or even high biomass systems can support rodent populations if field hygiene, again, field farm biosecurity, storage, drainage, and pest management are weak. The issue isn't necessarily agriculture itself, because we need agriculture. We need to feed our populations. The issue is how agriculture is designed and how it is managed. Large-scale monocultures, poor residue management, poorly sealed grain storage, irrigation canals, and encroachment into wildlife habitats can create conditions that favor the reproduction of rodent hosts. So yes, industrial farming can increase zoonotic risk, but it doesn't have to. Climate smart agriculture, sound biosecurity, integrated pest management, having biodiversity buffers, improved storage, rodent-proof infrastructure, again, hinting at the farm biosecurity, and surveillance can reduce the risk. Food security and health security should be go hand in hand.
Yeah, I think just now you mentioned the term biodiversity buffers. What does that mean?
So biodiversity buffer is the effect of having more than one species within a particular area. And why is that important? That is important because if you have one single species in very high number, the opportunity for one pathogen to propagate and to spread within that population increases dramatically. But when you have more than one species, it increases the biodiversity scale and scope. And what it does, it actually has a dilution effect on the transmission of those zoonoses. So in some ecosystems, high biodiversity can reduce disease transmission because pathogens are spread across many species, but not all of which are very efficient reservoirs. And so you will get a breaking of the transmission chain. Predators may also regulate rodent populations. So if you have not just one particular species, that population can be controlled and kept in check. Diverse habitats may prevent one highly competent reservoir species, therefore, from dominating, and that will reduce the risk of humans then coming into contact with those specific reservoirs. But when biodiversity is lost through deforestation, climate stress, wildfires, agriculture, or urban expansion, then the generalist species will often thrive. And rodents are what we would consider classic generalists. They reproduce quickly, they adapt well to disturbed landscapes, and they live close to humans. So if these species are competent vectors, then, I mean, competent vectors or reservoirs, then the spillover risk will increase. So it's important not to oversimplify because biodiversity doesn't always protect against every single disease in every single setting. But as a general One Health principle, degradation of ecosystems can remove ecological checks and balances that favor species, and it can then reduce the carriage or the passage of or transmission of pathogens within that population, and then decrease the likelihood of having a spillover event. So when ecosystems are simplified, disease systems can become more efficient because they're working in a singular species as opposed to several different species.
Are outbreaks like this, we see the hantavirus outbreak, we also see the recent Ebola outbreaks. Are these isolated events, or are they part of a broader shift in just how infectious diseases are emerging around the world as a result of the changing climate?
Each outbreak has its own local causes, but collectively, I believe that these events reflect a broader shift. Climate change, land use management, biodiversity loss, urbanization, global travel, even wildlife trade, food systems, waste mismanagement, all collectively which can be considered with the exception of climate change as anthropogenic activities. These are all changing how pathogens move from animals into humans. For hantavirus specifically, the concern is that the distribution of rodent reservoirs and the conditions for spillover may become less predictable. The MV Hondius episode also showed us how a local exposure can become a transnational public health event because people travel rapidly. And so I wouldn't necessarily describe these outbreaks as random isolated accidents, but I would describe them as signals from a destabilized human animal environment interface.
Okay. Are there already other diseases that are beginning to spread into new regions as the climate conditions change?
Yes, they are. We're already seeing climate sensitive shifts in several infectious disease systems. Namely, I can think of dengue, chikungunya, Zika, West Nile, malaria in some regions, Lyme disease, as we have more tick-borne diseases, and even leishmaniasis, and some other waterborne diseases such as Vibrio vulnificus. These are all influenced by climate and environmental change. The mechanism differs by disease. For mosquito-borne diseases, temperature and rainfall affect mosquito breeding, biting rates, survival, viral replication, even human exposure. And then for tick-borne diseases, warm winters can expand tick survival and activity. Then for waterborne diseases, when you have flooding and warmer, whether these are sea surface temperatures or inland water temperatures, these can all affect contamination, sanitation failure, and also the persistence of pathogens. So the important point is that climate change does not act alone. It interacts with poverty, housing, water infrastructure, waste management, mobility, health systems, and governance. Climate creates the pressure, but vulnerability determines the outcome.
Yeah, and also, by the way, on a microbiological level, can a warmer climate also influence how the pathogens evolve or survive and influence how our immune system works?
Yes, but we need to be precise, I think. Warmer environments can influence pathogen survival outside of the host, such as bacteria. They can proliferate at faster rates with warmer temperatures, and also replication rates inside of vectors. You have mutation opportunities with increased replication and then ecological selection pressures. But for some viruses, heat and ultraviolet radiation may reduce environmental survival. So for others, warmer conditions may increase vector competence or lengthen the transmission seasons. So there is an important immunological dimension. Heat stress, malnutrition, because if outside is dry and hot, you won't have a lot of food available. Also, poor air quality, displacement, crowding, and then concurrent infections can weaken human resilience. So climate stress can also affect animals, potentially changing viral shedding, their behavior, and also susceptibility. So the microbiological issue is not only whether the virus mutates faster, it is whether the entire biological system becomes more permissive for transmission. This is pathogen survival, host stress, immune function, vector biology, and human exposure all shift together. So climate change does not simply just warm the planet. It creates the biological operating conditions under which pathogens, hosts, and their immune systems interact.
Yeah, so if climate and environmental conditions are closely linked to infectious disease outbreaks, is it possible for us to forecast those outbreaks in the ways like we forecast hurricanes and floods?
I think we are not yet at that point where we can forecast infectious disease outbreaks with the precision of hurricane tracks. But I think where we are moving towards better probabilistic early warning systems. For hantavirus, useful signals include, rainfall anomalies that you mentioned, drought indices, vegetation from satellite, rodent abundance, rodent infection rates, land use changes, human mobility is important. Where do people go? How long do they spend? All these are important factors. Health facility syndromic data and laboratory diagnostics. I think we're going to get better with time, but I don't think we are where we would like to be or at the same level of preparation that you would have for meteorological forecasting. That has had several decades head start on infectious disease models. So the challenge is that disease outbreaks require several things to align: reservoir dynamics, pathogen circulation, human exposure, susceptibility, and detection. Climate is only one part of that chain. But with good data and its integration, we can identify periods and places of elevated risk. So the future is not necessarily a single perfect forecast. It is a risk dashboard. You can go from green, amber, red, and that kind of dashboard can guide, rodent control, the actions that you would take. Whether you issue public advisories, diagnostic testing, increase surveillance, waste site management, all these other things. So forecast risk early enough to prevent panic and late enough to be actionable.
You've also suggested there's a major public health blind spot in Latin America and the Caribbean, that hantavirus is often misdiagnosed because its early symptoms heavily overlap with diseases like dengue or Zika. So, as climate change intensifies and potentially forces all of these diseases to shift boundaries simultaneously, how can the public health systems distinguish them early enough to prevent outbreaks?
Well, yes, you really identified a huge problem for Latin America and the Caribbean. We have a number of overlapping disease syndromes, whether this is dengue, Zika, chikungunya, Mayoro, even Oropouche, influenza, COVID-19, leptospirosis, even rickettsial infections. All of them generate a febrile illness that is very similar. And so diagnostic testing is very important. So clinicians should ask the exposure questions, the recent travel, the recent contact with rodents, cleaning of enclosed spaces, farming, camping, all of these signals that point to potential exposure. Second, within the laboratory, you have to have testing algorithms that should be based on the clinical severity, geography, season, and exposure history, not only on what is the most common disease. In Barbados, for instance, and in the Caribbean, when you see dengue cases rising, the primary reaction or the consultation by medical practitioners can oftentimes lead to a dengue diagnosis without even laboratory confirmatory testing, because it may just be simpler. However, that doesn't give you the true perspective of what's clinically circulating at that time. It could be dengue. It could be, in my, for instance, PhD study, I found co-infections with dengue and hantavirus. So the whole clinical outlook and disease scope within Caribbean is changing. Every couple of years, we're seeing a new pathogen emerge, or at least we are discovering it. It may not be necessarily emerging, it maybe have always been there, but we never knew because we never looked. So having multiplex diagnostics and referral pathways will be very, very important.
To bring this all together, do you see outbreaks like this as a warning sign that we need to rethink our relationship with the natural world?
Absolutely. Absolutely. Outbreaks like this remind us that human health is not separate from ecological or environmental health. When we degrade forests because we want to exploit minerals, simplify ecosystems by removing some of the biodiversity, mismanage waste, we expand into wildlife habitats because we want to get closer to nature, intensify agriculture without the proper safeguards, and also ignore the climate signals. We increase the number of opportunities for pathogens to cross these species boundaries. But this is not necessarily as a fear of nature. Nature is not the enemy. The problem is unmanaged contact, ecological disruption, and weak preparedness, which all boils down to human behavior. We need a more respectful, intelligent relationship with the natural world, one that recognizes public health, climate resilience, biodiversity, agriculture, tourism, waste management, and urban planning as all part of the same system. So hantavirus, it's an ancient virus, but the warning is modern. The health of people, animals, and ecosystems, we can no longer govern them separately. We have to have transdisciplinary approaches to the way how we tackle diseases. And I believe that human behavior is by far the most critical factor that we need to target.
Yes, Dr. Kirk Douglas, thank you so much for joining us today.
Thank you very much.
And that wraps up this edition of Climate Watch. You can find more episodes on your favorite podcast platforms. Just search for Climate Watch and hit subscribe. Don't forget to leave us a quick review or share it with a friend. You can also email us at radio@cgtn.com with your questions or feedback. And stay updated on the latest climate stories with our Substack newsletter, Climate Choices. I'm Zhao Ying. Thank you so much for listening. See you next time.